Before closing out this course, I wanted to give a quick overview of a simple library for working with asynchronous requests and generator functions. Cancelable Asynchronous Flow is a tool created by Kyle Simpson in an attempt to make it easier to work with async actions and generator functions by making them look and feel more like normal async functions. Kyle Simpson is famous for his JavaScript works such as the You Don't Know JS book series and has helped thousands of engineers, including myself, become better at writing JavaScript. I highly recommend you check out his books online. You'll learn a ton from his work. So why would you need something like CAF? Async functions are familiar and easy to use, and for most cases the best option when working with async requests. The one downside is the inability to externally cancel an async function once it starts running. When I say externally cancel, think of how we control the flow of a generator function using the iterator it produces. We call iterator.next or iterator.return to control the function. That type of external control doesn't exist for async functions. CAF works by wrapping a generator function in a CAF function, which will return a promise when called. Whatever value you're returning in the generator will be the value the promise will resolve with. So you'll need to return something in the generator. These functions can be canceled by using the CAF cancel token. A cancel token has a signal object available, which you must supply to the generator function as its first argument. That signal listens for an external abort call, which when called will cancel the generator. It's probably best to see some actual code examples to better understand what's happening. So I'm going to use Code Sandbox again to create some example CAF functions. Since we use CAF for async functionality, we're going to need an API to make fetch requests against. For this, we can use JSON Server again, even with Code Sandbox. I'm using a node container template, which basically gives you your own server running within a container, terminal access included. I've also already added the code necessary to get JSON Server up and running. I'm using the same db.json file that we used in console log my food just for simplicity's sake. Now, CAF's purpose is to make a generator function look and work more like async functions. And what is the most common action taken inside an async function? Async requests, most likely to an API. So we're going to write a generator function that makes an API request to fetch users. We'll again use Axios as our async request library. Let's just fetch the user's data and return the Axios promise. Now let's create a variable to hold the fetch iterator. Calling it.next will return the Axios promise as the value, so you can do it.next.value.then and log the response data. There we see the users array, which is just one user. If we call it.next again, we can complete the generator function. Now let's add in CAF so that we don't have to call the generator to get the iterator. At the top of the file, require the CAF object. If you're using Code Sandbox and are getting errors related to a missing CAF polyfill, try to use version 7 of CAF instead of version 8. Now wrap the fetch generator inside a CAF function. Set this all to a variable called fetchCAF. Delete the iterator we were using before. Since we're using CAF now, the fetch generator function needs to accept a cancel token signal as its first argument. To create a token, you instantiate it with new CAF.cancelToken. Now let's call fetchCAF, pass in the token signal, add .then, and console log the response. We're getting the same output as when we were calling the next method on the iterator, but we're writing it all as a promise. We aren't using the cancel signal yet though. I want to show you how to cancel the promise, and to do that, we'll use CAF.delay and CAF.timeout. CAF.delay is basically a promisified set timeout with the ability to be canceled. CAF.timeout gives you a timeout token that is set to abort after a specified period. This is a very common use case that we deal with, where we may want to cancel a promise if it's just taking too long to resolve. Let's update our token previously created with CAF.CancelToken by using CAF.Timeout instead. Set the first argument to 300 milliseconds, and the second argument will be the string, "This is taking too long." The second argument is a message that will log when the time elapses. Now let's add a delay to the generator function to simulate a long-running request. Add yield CAF.delay with the signal as the first argument and 400 milliseconds as the second argument. Why are we using CAF.delay and not a normal set timeout? Well, if we use a normal set timeout, we would have to take care of canceling that timeout manually. There are manual ways to keep track of the timeout's name for clearing later, but this adds more work for the developer. Here's a perfect example of what I mean that I've grabbed from the CAF documentation. Here we have a function called delay that returns a promise-ified set timeout. There's a 5-second delay waiting at the bottom here, which will abort the token when elapsed. The problem is, in the main call, we're only waiting 100 milliseconds until it completes. The 5-second timeout won't automatically cancel and will continue running until the full 5 seconds passes. Again, sure, we could try to handle canceling the set timeouts manually, but with CAF we don't need to do that when using the timeout token. Now back in the code, we need to update the fetchCAF call by not only passing the signal, but the entire token. This is necessary so that CAF can cancel not just the fetchCAF call, but also the delay call at the same time. If you were to abort the timeout token, we want all places it's been passed to get canceled as well, and in this case, it's the CAF.delay where we are passing it. Let's add a catch block to the fetchCAF call to make sure we are handling the case of canceling the promise. In our example, we are seeing that our function is being canceled. The Axios call is never being made, and our catch block is logging the "This is taking too long" message. We've learned that cancelable async flows lets you use generator functions in your async flows so that you can easily cancel requests if needed. This involves creating and using a cancel token that is passed to the generator and used to listen for an external abort call. We use the CAF delay and CAF timeout to wire up cancellation of a timeout and the generator function at the same time using a single token. One of the most common use cases is using the timeout token to cancel an async call that is taking too long. That's super helpful. And that wraps up this course. I hope that you've gained a more solid understanding of generator functions and iterators. These are both relatively new to the JavaScript language, but have a lot of potential for everyday use. I really enjoyed making this course, and I hope you enjoyed taking it. You can follow me on Twitter at MWQ27, and you can see some of my blog posts at marcuswoodson.com. Follow me here on Pluralsight if you want to receive updates when I post new content. And finally, if you develop web applications and want to test their UI using a tool other than Selenium, check out my course End-to-End Web Testing with Test Cafe Getting Started. Test Cafe is a great tool for end-to-end testing that doesn't require a WebDriver and supports TypeScript right out of the box, along with the newest JavaScript features. You can test your application across all major browsers and mobile devices without the need for plugins or add-ons. Thanks again for watching. Happy coding!